Hello, today we are at the Zero Density booth at NAB 2026 and we have Klaus Weber from Grass Valley. He is the director of the product marketing at Grass Valley, and we will talk about their very good cameras. We have LDX 150 here, and Klaus, please go on.
Yeah, Kuban, thank you very much for the introduction. It's really nice to be here at Zero Density on the booth, and it's also nice that you are using our cameras, of course. But since we have a very long cooperation, the two companies
it's a decade old. From the first day, starting in 2016, we started with LDX cameras in trade shows. Now we also use them in our R&D.
Yeah.
So we have quite an experience keying, color difference keying with these cameras for over a decade now.
Yeah, so our company is a little longer in the industry. Grass Valley more than 60 years, but the camera business also more or less the same time span. It's coming from the previous Philips times. So we have the camera technology which we develop completely and also now produce again in Breda in the Netherlands, so in the center of Europe. So, and one of the things what we do since many years already, we make our own imaging technology. So we develop in-house in the camera factory our own CMOS images. So we started many years back with Plumbicon tubes and then introducing CCDs, but we also introduced CMOS actually to the broadcast industry. That's going back to 2012. So it's a very similar time as you are working in that field.
LDX80, I remember LDX80. It was an HD camera. It was progressive, 3G capable. I first used the compact camera, and for the Rec 709 colors and HD images, it was at that time performing very well for color difference keying.
Right, and that was a reason why we introduced CMOS imaging technology in that time, because CMOS is optimized for progressive operation, where CCDs only perform best in interlace. But interlace and keying is two things which does not work so well with each other. But on the other hand, also, I mean, all the modern display technologies, independent if it's OLED or LCD, are all progressive. So interlace signals and progressive screens does not work together. So, and that was one of the key reasons why we went so early with CMOS imaging technologies. But we didn't stop there. So as you mentioned, LDX80 was HD. But now in the LDX 100 series, we use UHD images. It's actually a 2-3 generation more further developed imager. So in the 150, we use 3 of them. It's 3 native UHD images with 8.2 million pixels approximately each. And since it's a 3-imager camera, we use a prism beam splitter with the 3 images aligned to them.
The alignment is extremely important to us because we look for the color component differences between RGB values. If it is shifting even a half a pixel, it's actually hurting the color difference algorithms. It should align on every pixel as good as you can.
Correct. And you know, we do inside our camera factory our own alignment. So we have developed machines which are mounted in a clean room where we do the alignment for the 3 images. And we do that already since we have CCDs in the factory. So we have a long experience. And mentioning the prism beam splitter is used in any 3-chip camera around the world. And is a technology developed by our camera factory. We received an Emmy award for that one. In addition, we received 6 other Emmy awards for different technologies we have introduced over the years. And one of them is prism beam splitter, which is the basis for having a RGB signal well aligned to each other. And so we can make sure that our images are aligned in a way that they are having not a half a pixel.
This is very important because they should really align, because we are looking to the RGB values.
Correct.
And if it's sub-pixel, you can't really fix it digitally, not completely.
Correct. You mentioned it, fixing it digitally. So what we do is we guarantee that our images are precisely aligned. If not, then they will be taken out and will not be used or repaired or whatever. So we make sure the alignment is inside sub-micron, let's say, deviation or tolerances.
Yeah.
But of course, there is still the optical effects, the chromatic aberration errors, which cannot be completely avoided, especially on a zoom lens. On prime lenses, you might have some possibilities to have a lens which gives you a quality even in the corners, which is less than 1 pixel offset. But in a zoom lens for 3 imager cameras, you cannot avoid that during the full zoom range you get a perfect signal. So therefore we have all developed many years back what we call the Klaus technology, chromatic lens aberration and sharpness solution, where we align or we control the image size horizontally and vertically to reduce the errors which are introduced by the chromatic aberrations from the lens to a level which is more or less close to be invisible.
Okay, this is good to know. We are always recommending in our user guide that you should utilize that correction of the camera if available. Otherwise, when the pixels go to the corners, the alignment issue between the color channels are optically getting worse because they have a different value of refraction through the glass, I believe. I'm not an optics expert, but those corners are really looking bad. But once the camera and the lens talk together and the camera is inversely correcting that for the red and blue channels, I believe, you may be keeping the green as the master, and that correction is really visible, and that functionality is vital for color difference keying.
Yep, but you know, for a complete, let's say, for a perfect end-to-end solution, there are a few more things inside the camera which are important. So it's the way how the colors are separated, how we separate red, green and blue, the exact characteristic of the prism beam splitter, because it defines, for example, also how much electronic compensation, the matrix correction we need. Then also matrix is very important to get the right color reproduction from the camera. Maybe not in a green screen, but for face colors, skin colors, to have a more natural reproduction. And this is important that the camera takes care of all these things. So a good quality filtering with a good quality color correction at the end, or matrix addition at the end, can make quite a big difference in the overall performance.
To be honest with you, when keying, we are actually disabling those matrix multiplications and the sharpening filters and the like, because actually the more raw the sensor data that we can access to, the better it is for the color difference algorithm. And we apply all those processing in our node graph. Actually, what you do in camera after keying. That's the processing order that we are recommending.
Okay. I did not know that, but of course I understand the background for a green screen application. But since you are also doing other applications with LED walls involved, and then the color, let's say, characteristic of the camera becomes even more important. That you are able to align the foreground and the background together, have the same constant look and so on. And there we have a lot of things inside the camera which helps to improve.
So Klaus, it was very good to see you here again. And thank you again for a decade-long support that you have given to us during all the trade shows, during R&D, and whenever we needed the support from you.
It was a pleasure, and I hopefully continue for many more years with that partnership.
Thank you.